Interval Notation by Michelle Yang and James Lohr.
You'll learn how to write, read, and understand what interval notation is. We'll also teach you different ways interval notation can be used. When learning about interval notations, you should already know how to read a graph. You should also know about maximums and minimums, and it will be helpful if you're familiar with fractions and square roots. Next, Michelle will teach you the differences about how to use brackets and parentheses.
So in interval notation, they use symbols. And some that I will be introducing today is parentheses, brackets, and union. So parentheses are, value that are not included. And how you can determine them are, if you were to look at a function, you can determine them by finding the inequality or of greater than or less than. And if you were just to have a graph, you can tell that it's an inequality because it's an open dot. I like drawing a little face with it. So if it has any parentheses, it will be using like an inequality like this. Let's put 0. Or like on the graph, it will have an open dot. For brackets, there are values that are included. And they will use inequality of greater than or equal to. And it will have a fill-in dot. So if you were to see something like this, then it would be using brackets instead of parentheses. And it will have a fill-in dot on the graph. Then there's union. What a union is basically it joins two set of notations. It's normally used when in like piecewise where the graph are have breaks in them, or in restricted domain or anything that's restricted. So an example of that would be if I was to have a graph and here's one function and it does so this would be negative infinity, positive infinity, and let's name this point A and B. So if anything, a union sign would be this point be positive. So basically what that stands is like by looking this way from this way, you can, as you can see from the graph, it has a break right here where there isn't any point of the graph that's here. So from this point to here is part of the graph, and it takes a break here, but from this point and this point is also part of the graph. So a union basically kind of joins them together. And that's all for the symbols.
Now I'll teach you about increasing and decreasing intervals. Increasing intervals is when the graph heads toward higher positive numbers, and decreasing intervals is when the graph heads toward lower negative numbers. On this graph you can see that the decreasing interval starts at -4, 8 and ends at 0, -5, while the increasing interval starts at 0, -5 and ends at 4, 4. Here's an example of a piecewise function. As you can see, the graph is broken up. However, since each open dot is paired with a closed dot on the same point in the x-axis, that means the domain should be negative infinity to positive infinity, neither included. As for the range, it should be including 0, and even though the graph is broken up, this line shows that while the y-axis may not be defined in one point, it is defined in another, meaning the range should be including 0 to not including positive infinity. For the decreasing interval, the domain should be negative infinity not included to 0 not included. For the increasing interval, it should be, or the domain should be, 0 not included to 1 included, union 2 not included to positive infinity not included. And this part of the graph is constant.
So I will be showing you an example of how to solve for a domain algebraically. So if we were to have an equation like this, and this is also a restricted domain as well. So looking at this function, the first thing you would do is that the denominator cannot equal 0. This cannot equal 0. And that is our restricted domain. So because of that, we will have to find out what x cannot be. So x cannot be negative 3. So what this basically means is that negative 3 is not defined in the graph. So the x value, negative 3, will not be defined in the graph. Meaning if you were to find the domain, which is all possible x value at least. And so the domain would be that it will be from negative infinity to negative 3, because that's restricted. It cannot be, it's not defined. And because it's not defined, we'll use a parentheses. Union, because even only negative 3 is not defined, but everything else is. So continue onward. And that would be our notation for this. So I will be showing you another equation that has restricted domain, and this time we'll be focusing on square roots. So in a square root, you can't have any negative numbers. No negative numbers. Negative. So because there's no negative numbers, what I would do is I will make a number line, 0, and I will use the x-intercept, which is negative 3. So I will plug in find values on this number line, and I'll plug it in and see if it equals, if it's a negative or a positive. So from over here, I'll use negative 4. Negative 4 plus 3 equals negative 1. So values on this side of the equation are negatives, and that's not what we want. So then we'll go on to this side. So anything after negative 3. So let's do negative 2. Negative 2 plus 3 equal positive 1. Positive. So everything on this side of the graph is positive, which is good. So this is the domain. So then for the domain, we can look at this equation. So let's see if negative 3 plus 3 equals 0, and 0 is okay being inside the square root, so then it would be okay to include negative 3. So we'll use brackets. Brackets negative 3. And we don't use anything over here because over here is negatives, and we don't want to use negatives. And everything on this side would make it positive, so it'll be okay if it heads towards this direction, which is positive, and this is negative. So it'll be positive infinity. And that is your domain for the equation. So these are some more examples of how to find domain and range for other equations without looking at the graph. So if we have an equation of, let's say, a line, just a line, and if this is what you see and it's asking you for the domain would just be this. Because there isn't any inequality to stop it or restrict it. So basically what this means is that it's a regular graph heading from infinity to infinity. Those are just for lines without restriction. And by restriction is normally inequality. So these. So for a parabola, use regulars too. The domain would be, this would be domain and range. So for the domain, it would be negative infinity to positive if there is no restriction. And for the range, it differs because with a parabola, it's basically this. So you have to find the minimum, or if anything, the maximum, depending on what your graph looks like. So you'll have to find that point, and you have to find the y value. So there will be the x and the y, starting from negative upwards. If it was this equation, the point would be 0, 0. So this would be including 0 to positive infinity. That would be our range for this specific equation. So if it was one like this, it would be, since it's heading to infinity, and it will stop at whatever the value of y is. Next up, we'll do practice problem. Please pause the video and then try to do them by yourself, and then we'll go over it together. First, we'll start off with a piecewise function. Please pause the video and try to solve it by yourself before we go over it together.
Okay, so for this piecewise function, the process should be pretty similar to the last one. Even though the graph is broken up, because the closed dot is on the same x-axis point as the open dots, the domain doesn't need to be unified. And like last time, the range should start at 0 included and go all the way to positive infinity not included. The domain for the decreasing intervals should start off as negative infinity not included and go to 0 not included, union 2 not included, all the way to 6 included. And for the increasing interval, it should be 0 not included to 2 not included. Any closed dots by themselves count as constants.
Next, we'll be doing a restricted problem. Please pause the video and try to solve it yourself before we go over it together. Okay, so the denominator cannot equal 0 because in a fraction, you cannot have the denominator equal 0. So the equation in the denominator will set it to 0 and see what x cannot become. So basically, you'll have x plus 53 equals 0 and subtract 53 from both sides, and that would mean x cannot equal negative 53. So basically what this means is that in the domain, the x value, it cannot become negative 53, because in the denominator, negative 53 is undefined, because if x was negative 53, it will cause the denominator to be 0. So since that's the only restriction in the domain will be negative infinity to negative 53, not including 53, which means in parentheses, union to negative 53 to positive infinity, because 53 is the only point in the domain that is not defined, so it will be removed completely, but in the graph, it's still on continuing in the other points. It's just that one point that's not defined. These are some links that we use to form our video. They are really useful, and I recommend you look at them if you're still confused about interval notation. But that's it for our video. Thank you!